Hey yo, what's up my little coders? In this tutorial, I'm going to teach you Java streams. So, if you're new to the streams in Java, or you already have some understanding but want to learn more, then this video is for you my little coder. Let me quickly talk about what Java streams are and why we need them, and after that we can jump straight to the code. Okay, Java streams. What are they? The Stream API contains classes for processing sequences of elements. This is the main purpose of it. Java streams have been introduced in Java 8 version. Streams allow us to leverage multi-core architecture without the need to write any specific code for it, which can make them very efficient when we need to process big amount of data. Leveraging the multi-core architecture using the Java streams is not the main purpose of this video, however, I will talk about it in the end of the video in a bit more details. Streams bring functional programming to Java, and the world is moving towards the functional programming, so this is very important as well. Okay guys, I think it's enough for the theory, let's write some actual code now. And as I told you, the Stream API contains classes for processing sequences of elements. That's why we definitely want to have some sequences of elements in order to process them, right? I created the list of products where the product is a class which I created myself. Think about it as a, I don't know, as a product from the online shop like Amazon. In our case, our product would have just a name, so the name of the product, then it would have a price, it would have a discount. Think about it as like 5 or 10% off, so the discount in terms of the percentage, and it would have some attributes. And attributes is a hash map, so we can store whatever we want. Let's say if we would sell some phones, what can we store here? Maybe capacity, the font color, screen size, some other things, just all the attributes which our phone might have. Then I created a method to populate some data so we can process it. As you can see here, I'm just creating for each product, I'm creating first of all some attributes. Let's say this product would have the color as black, then the screen size of 4.7 inches. Then we create this product. We just simply say that it's iPhone 8 64 gigs black. So this is our title, our product name, then the price 280, I don't know, dollars, euros, pounds, whatever is more comfortable for you. Then it would have the discount of 5% off, and we also adding these attributes which we define here. And we do the same thing for 4 more products. So in total we have 3 iPhones and 1 Google Pixel and 1 Samsung Galaxy Note 10 Plus. Now let's actually do some processing with all of this data. But before actually showing you the Java Stream API, let me first of all write the code without any Java streams. Just how would you do it if, for example, the Java Stream API would not exist? Imagine I want to just return a list of all the iPhones. So let me write it. Example 1. Okay, list of all iPhones. How would I do it without the Java streams? Probably I would have a for loop. I would iterate through all of my products. Then I probably would have a if statement, right? I would probably get the title of the product, so I would get the name, which in this case, for example, for the first product would be iPhone 8 64 gigs black. Then because someone might write iPhone with the capital I and P, someone might write like that. Just to reduce the errors, let me just convert the name to lowercase, and after that I will check if the current string contains the word iPhone. If it does, I probably want to populate the data in the new array, so let me create it. And if I see that the current product is an iPhone, I just would add it to the list. And then let me print everything. Okay, if I run this code, we expect to see 3 iPhones. Yeah, and this is what we get, 3 different iPhones. So this is correct. And this is how we would do it with the simple for loop. This is also called the imperative approach. Now, let's compare the imperative approach with something what is called declarative approach. So, with the Java streams. How would we do exactly the same thing, but using the Java streams? Okay, let me create a new list. Let's call it example 1. Now we need to take our data, so our products. Then whenever you want to use some Java streams functionality, then you just first of all need to do .stream on your data. So now you can leverage the Stream API. And instead of for loop, the Stream API has something what is called filter. Filter basically returns a stream consisting of the elements of this stream that match the given predicate. So what will be our predicate? First of all, when we filter, we need to get the current, object. And in order to get it, you just first of all need to write something. You give it a name yourself. It can be a letter P, or you can write product, or you can write, I don't know, pickle, whatever you want. You call it yourself. Of course, let's call it something what would make sense. Let's call it product because right now we're considering the product from the products. And then, okay, we take this product and basically, we can call exactly the same function because right now we are on every product we are filtering. So product get name, the lowercase contains iPhone. It's not the end because right now my IntelliJ complains that the part here is not the list of products, but it's the stream of products, which is okay because yeah, we call the stream function. However, after we did the filtering, we also want to, store the results somehow. And we want to explicitly say using what data structure we want to store our results. So we need to call another function collect, and we need to specify that we want to collect everything as a list. I mean, it could be a list, it could be something else, but you need to specify that. Now let's compare if this returns the same results as this. Okay, let me just separate it somehow. Okay, but instead of the iPhones, let's do for each on the example 1. If I run it, you can see that we get exactly the same results. However, here, using the imperative approach, just look how many lines of code we needed to write. Whereas here, you just needed to write one line of code and it looks much better. It's straightforward. And if, for example, I cannot convince you that this is much better than this, then guys, if I cannot do that, then someone else would do it, because if you haven't found already your first job, believe me, if you write something like that on your first job, most probably your code just would not pass the code review and someone would ask you to use the Java streams instead. This is the reality, guys, so definitely make sure you learn the Java streams and watch until the end of this video, because this is just one example and we are going to cover many more examples in this video. Okay, this was the first example. I showed you what is the filter function and how to use it. Now let me show you something else. Imagine we want to get the list of all the colors from the attributes, and if we would want to write it using the for loop, it would be even bigger for loop than in the first example. Now let me show you how easily it can be done with the Java streams. Okay, it would be example 1. This part would not change. However, because we want to return the list of colors, it would be the string instead of the product. Actually, let's not just return the list of colors of all of the products, but let's return the list of colors of iPhones. Let's make it a bit more complex. However, if we want to return the list of all the iPhones, we can reuse this piece of code. So we filtered by the product name. Then on the next line, we can call another function to collect only the colors. This function is called map. Before calling this, we would make sure that all the products which would go inside this function, they will be iPhones. And again, we need to give it a name. As I told you, you can call it whatever you want, but because before that we filtered by the iPhones, let's call it iPhone, because we would consider here only the iPhones. Then if you want to get only the colors, map, basically what does it do? It returns a stream consisting of the results of applying the given function to the elements of this stream. And iPhone is still a product, so we can just get the attributes, because this is the place from where we can extract the colors. Then we're inside the hash map, so we need to get the value by specifying a key. It would be a color, and then in the end, again, we need to collect everything to a list, because list is what we want to return. Now, this is all what we need to do, guys. Now, if I would print it, what we will get, let's see, we will get the colors of all the iPhones. Let me double check that this is correct. Here, the first one has the color is black, then the next one is red, then we have one more iPhone which is green, and 2 other phones are not iPhones. However, if we change our mind and we want to return all the colors which we have, we can just simply comment out the line 15. And if I will rerun my code now, you can see that we get all the colors. And yeah, we get the color of the Google Pixel 6 Pro and Samsung Galaxy Note 10 Plus. However, you can see that we have some duplicates, which makes sense because we have the Google Pixel 6 Pro in a black color, and we also have our iPhone 8 in a black color as well. So if you would like to remove the duplicates on this map function, we could simply call distinct, which would remove all duplicates for us. Let me compile it again. Now you can see that all the colors which we get are unique. And, very simple. Imagine doing the same thing, but using the imperative approach with the for loops and plenty of if-else statements. Okay, let's move on. Example 3. Imagine if we would like to return the average price of iPhone. How would we do that? Again, we can do it using the Java streams, right? So the return type would be a double. This part of code would stay the same as usually. Then if we want to get the average price of iPhone as before, we should filter by the product name, which would contain the word iPhone, to make sure that we will calculate only the iPhone's average price, but not the average price across all the products. Then we can use the map function again, right? And to calculate the price of iPhone, the tricky part is that we also have a discount. And it would not be just iPhone dot get price. No, we also need to consider the discount of the iPhone. And to do that, we can get the price of the iPhone and subtract from it the price multiplied by the discount. I don't know why my IntelliJ complains. Oh, I missed the dot here. Yeah, now it recognizes the get price. So I get the price of the iPhone, then I do this price minus iPhone get price multiplied by the discount. So if price would be, let's say, $100 and the discount would be 5%, then price multiplied by the discount would give us $5. And then from the total price, we subtract $5 and we get our final price of the product. So again, what we have done, we filtered by the iPhones, so we consider only the iPhones. After that, inside the map function, we calculated the price of each iPhone after applying the discount, and right now we have a stream of the prices after a discount. We can move on and calculate the average price now. We can just simply call .average and it would calculate the average price for us. However, the Stream API cannot recognize this average method. Okay, this is because the average actually works not on the map method, but on map to double, which is exactly the same thing. However, it just makes sure that the result of this operation would be a double, because only with the doubles the average function would work. However, another complaint, because yeah, in some cases, imagine we would filter by Nokia, but we don't have Nokia inside our products, right? So it would be impossible to calculate the average price. That's why we get suggested that we need to change the variable type of the double to be the optional double, because sometimes we might not get a result at all. And now we can see that, okay, we don't have any errors. Perfect. Okay, if I run it, you can see that we get the average price of 441.6333333. However, I want this variable to be just like a double. I don't want to have this optional. How can I do that? Okay, I can just specify what would be the default return value in case if, for example, this operation is not possible. In case if we don't find any iPhones or something else, whatever we're looking for. And now you can see that we get the average price. And this should be the average price. And this is all what we needed to do. Again, guys, imagine doing with the for loops and if-else statements. This looks much better, and once you get enough practice, this would be much simpler to implement as well, believe me. But, okay, let's move on, guys, because I have some other things to show you as well. Some very cool and exciting things. What else the Stream API can do for us? Imagine if we would want to sort by something. Let's say we would want to sort by price. If you want to sort the products by price, probably we are going to return the list of products in the end. So example 4, this thing will be unchanged products.stream. Then we can just simply call the function called sorted. And inside the sorted, because we want to sort by price, we can use the comparator to do that. And comparator can do the comparison based on the price of the product. And after we collect everything to the list, this will be all what we need to do if we would like to sort our products by price. Let me prove it to you. Let me just quickly do a for each and print everything what we get here, and you would see it yourself. Yep, 280, 370, 410, 800, 1000. However, you can see that here, we start from the lowest price and we go to the highest price. What if I would like to do the sorting in a reversed order? And if I would like to do that, it would be super simple, because here I could just call one extra function called reversed. And if I would run it, you can see that now we sorted everything in a reversed order. Simply as that, guys. Also, if I don't want to sort everything, but I want to return, let's say, the product with the maximum or minimum price, I can do it very easily. I can just simply call the max function. Again, same as here, I would need a comparator which would compare the things for me, and in the end I can just simply call .get. Simply as that. Literally just one line of code. Products.stream, then we're calling the max function. Comparator, we need to specify by what exactly we want to compare, and we want to compare by price. Then if I just would simply print it out, let's see what we get. We should get the product with the price of 1000, because this is the highest price. And we get it, guys, 1000. Same if, for example, we would want to return the product with the minimum price. We could just call .min instead of .max. Let me see what we get. Yeah, 280. This is indeed the product with the lowest price. Because yes, this is the product with the lowest price. All the other products have a price greater than this one. And this is all what we needed to do, guys. Simply as that. Now, let me show you one more example. If you know the databases and you have queried something in the past, you probably know what is grouping by, let's say, in the SQL language, right? We can do the similar thing using the Java streams. Imagine I would like to group by the color. If you want to group by color, we probably would like to return a hash map where the key would be the color, like black, red, green, whatever it would be. And because multiple products might have same colors, we would need to have a list of them. However, I don't want to return the products, I just want to return the product names. In this case, how can I do it, guys? How can I do it? Pause the video and try to implement yourself if you know how to do it. But if you don't know how to do it, I will show you how to do it, no worries. Okay, products.stream, same as in any other example. Then, because in the end we would want to collect everything together, I can call the collect function straight away. However, it's not going to be a list, it's going to be something else. Inside this collect function, again, as before, I would call the collectors. And then the collectors has a grouping by function, and this is exactly what we need, so we would call it. Okay, we give it a name, P, for the product. Then, from the product, in order to get the color, we know that we store the colors inside the attributes, right? I would simply call product.get attributes to get the color. Actually, it would get the attributes. Then, because it's a hash map, the attributes is a hash map, I would call get to get the value of the color, specify a key. Okay, it complains for us, but I think that if I would implement the second part, yeah, the error goes away. Okay guys, again, so we are grouping by, we need to specify by what exactly we would group, and we would group by the cover. However, imagine this is a hash map. This product might have the cover as an attribute, but in some other cases it would be missing. What would we do in this case? In this case, instead of getting the cover, we can do just simply get or default, and we would specify our default value. Let's make it a string, no cover. And then after we grouped by the cover, we can just call another collector, collectors dot mapping here. Same as before, when we do the mapping, it means that, we want to get not the whole object, but part of it. And we can just simply do product get name. So we just want to get the name. We want to get the list of the product names. And then also, as before, these product names, we need to collect them into a list. And same as before, collectors dot to list. Simply as that. Now, if I would run it, let's see what I would get. If I would run it, yes, we see that our grouping worked as it should. So we have one iPhone in red color, then we have another iPhone in green color. In the black color, we have one iPhone and a Google Pixel 6 Pro. So this is a list of two products. If, for example, I would comment this out, then two other phones would be captured as no color because I removed the color from the attributes for them. Simply as that, guys. Okay, just one more thing. Remember that in the beginning of the video, I told you that Java streams can leverage the multi-core architecture of the computers in order to execute the processes in parallel, because there's always can be only one process per one core. And if, for example, you're running something on the machine which has multiple cores and you run everything in the parallel, it can really improve your performance and execute the things much more quickly because you would execute a lot of things in parallel. Okay, so one thing is that by default, everything what we called before, this is not running anything in the parallel. It is only one process and there is no distributed processing. However, if you want to run the things in parallel, we can simply do that by just instead of calling the dot stream, we can call the dot parallel stream. And let me just prove it to you. Let me just print the product names. And also, apart from printing the product name, let me also print the current thread name. And at the same time, I would do the same thing for the simple dot stream. If I would run it, you see on top we have our parallel stream, and here we have our normal stream. My machine has multiple cores. You can see that it printed the first product using the main thread, however, printed the second product using another thread, then the third product using another thread again, then again there was main, there was another thread. So it actually proves to us that the things been executed in parallel, whereas for the simple.stream, you can see that everything was printed using the same thread, so the same core. You can also see that, when we're running the things in the parallel, it would always mean that the order of execution might be different. For example, here we printed the things in the same order as we stored them in our list. The first one was the iPhone 8, then iPhone XR, then iPhone 13, but here we considered that the order is slightly different. And if, for example, now I have iPhone 13 and after that iPhone 8, if I would rerun it, you can see that order has changed because it's the execution of the things in parallel. So we don't specify the exact order, we just execute the things as quickly as we can, and the order might differ. But, this is one option to improve your performance when you're working with some big amount of data. And this thing might be very useful in some cases when the performance is very important. Okay guys, I think this is all what I wanted to cover in this tutorial. However, this is not the end because I prepared some exercises for you. The link to this code will be attached in the description below. From the GitHub, you can just clone this repository and you will be able to find the file called exercises. And if you want to test yourself, I created some tests so you can just run them to see if your implementation is correct or not. Because once you will implement these functions, and if you did everything correctly, you should be able to pass all the tests. So this is your homework, guys. Please make sure you do it because practice makes perfect. In case if you're really stuck, I also have the solutions here, but make sure you don't look at this file until you really try to implement it yourself. This is all from me. Thanks for watching, guys. If you enjoyed this video and you think that it was useful to you, please give this video a like and subscribe. And thank you, and see you later.